I've had some questions about number 2 on that all limits handout that we had today, and rightfully so. The solutions that I posted for this problem were basically incoherent. I even changed the cosine to a sine halfway through the problem. So what I thought I'd do is whip up a little video and see if I can be slightly less silly in explaining the use of the Sandwich Theorem to demonstrate that this limit in fact is 0. Okay, so most of these problems start out the same way. We have a trig function. In this case, it's the cosine of 50 pi over x. And just remember that the cosine function is always trapped between -1 and 1. The highest point the cosine function will achieve is 1, and the lowest is -1. Right? Those are the highest and lowest values on the unit circle. So we start with this, and we just work with the trig function. And then I notice that my trig function has been multiplied by x to the 4th. So what I really want is an x to the 4th in here. So I'm going to go ahead and multiply by x to the 4th. But if you do that, you have to multiply by x to the 4th to all of the parts of the inequality. So I'm going to multiply by x to the 4th here. I'm going to multiply by x to the 4th here. And when I do that, what I end up with is negative x to the 4th less than or equal to x to the 4th cosine of 50 pi over x less than or equal to positive x to the 4th. And then the strategy for the sandwich theorem is we ignore the middle for a while and we just work on these two boundary functions. And instead of doing the limit as x approaches 0 on that x to the 4th cosine 50 pi over x, I'm going to do the limit as x approaches 0 on negative x to the 4th. And that's a simple substitution. When you plug 0 in for x to the 4th, you get 0. Negative 0 is still 0. So this limit down on this side is 0. That's good news. We've got one limit done. We do the same thing down here on this end. We send x to 0 on this guy, and we hope we can do this limit. We plug in 0 by substitution because we always try substitution first. And lo and behold, x to the 4th, or excuse me, 0 to the 4th is also 0. That's good news. So we have two limits. Not only that, but the best news is that those limits are the same. So the Sandwich Theorem says if you've got a function that's trapped between two other functions and you can compute the limit on the boundary functions and they are the same, then the middle function has to have the same limit. And then what we do is we write all this math out and we say therefore, and usually mathematicians use this symbol with 3 dots to mean therefore, and then you just state your answer. Therefore, the limit as x approaches 0 of x to the 4th cosine of 50 pi over x to the 4th equals 0, and then you have to say by the Sandwich Theorem. If you're going to apply the Sandwich Theorem, make sure you state it right in your answer. Hey man, I use the Sandwich Theorem. Usually we just put by the Sandwich Theorem. Okay, so we start with this inequality where our trig function is trapped between -1 and 1. That works for cosine or sine. And then we multiply in the stuff we need to make it look like the original problem. Sometimes you have to divide, but in this case we multiplied. Once you do that, you operate on the end functions. So we don't operate on the middle. We operate on this guy here and this guy here. We do the same limit that's in our problem. So I send x to 0 on both of these, and I got the same limit on both of them. If both of the boundary functions have the same limit, the middle function does. Therefore, we found the limit equal to 0. Now, this is hard to take until you practice a few of these. But remember, we can always investigate a limit using a graph. So let me show you that the graph of this function does support our finding here that the limit is 0. Take a look at this graph. So as you can see, I did type the function in on Desmos, and notice that as I get close to x equals 0, my y values are getting close to y equals 0, which is what we came up with. So this is a crazy looking function. There's lots of weird stuff going on. But as you get closer to 0 on the x-axis, the y value is close to 0. And that's really what we're looking for when we look at limits. We are trying to look at what's happening when we're really close to a certain x value on the y values. And these y values are 0. So between my sandwich theorem and this graph, I hope you'll agree that that limit is 0. And we probably should practice a few more of these, certainly before I throw anything like this on the quiz. So don't panic, but hang in there, and we'll keep going on this. Take care.